Today we're going to be taking notes on scientific notation. Now I just want to go ahead and I want to go back to our notes that we did on powers of 10, talking about that in expanded form. And we had this here in our notes. And it says a times 10 to the n. This is scientific notation. Now the rule is that 1 has to be less than or equal to a, which has to be less than 10. All right, so the number that we use for a has to be at least 1 and less than 10. And n has to be, that little power has to be an integer. So that means it can be a positive or a negative number. So when we go to our actual notes that we have here dealing with scientific notation, we want to go ahead and use that information to help us out. When I look at this first number, 1,200,000,000, it might seem a little bit daunting, but it's actually easy to be able to turn it into scientific notation. There's a couple of ways that we can look at it. One way we can look at it is I'm going to rewrite the number 1200, just so it's large enough for me to write here. And after I write the number, I'm going to put a decimal place right here. Okay, the decimal always comes at the end unless it's noted somewhere within the number. So now what I want to do is I want to move that decimal until I figure out a number that's 1 or less than 9. So I'm going to move it 1, and I want to count 2, 3, 4, 5, 6, 7, 8, 9 places. As soon as I figure out what I moved it to, I'm going to put 10 to the 9th. I moved it 9 times, so I'm going to have 10 to the 9th. And remember, if I was to write 10 to the 9th or figure out what 10 to the 9th was, it would be 1,000,000,000. So now I need to multiply it to the decimal that I've created. The decimal I created is 1.2. So I'm going to say 1.2 times 10 to the 9th. I've been able to take a number that's in standard form and put it into scientific notation. The next number I have is 60,510,000. I'm going to put that decimal right there. So again, I'm going to move that decimal until I have a number that's less than 10, greater than 1. So I'm going to move it 1, 2, 3, 4, 5, 6, 7 times. So I have 10 to the 7th. Now I need to go ahead and look at all the numbers that I have here, and I need to write them all down. The zeros that are left, I don't need to write those down, but I do need to write this down, which is 6.051 times 10 to the 7th power. All of those numbers, even though there's a 0 there in between, I need to include that. And that 51 is important to the value of the number. You'll see that a lot, especially in science. Next, I have a decimal. I have a number that's very small in value. So I have 0.00000. Wait, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 3. Okay. There's my number. I'm going to go ahead and just rewrite that in blue. 0.1, 2, 3, 4, 5, 3. Now I want to go ahead and move that decimal until I have a number that's greater than 1, less than 10. But now I have to move it to the right instead of to the left. My decimal is already in place. I don't need to draw a decimal here. So I move it 1, 2, 3, 4, 5, 6. 6 places. Now, since I'm dealing with a very small number, I'm going to write 10, but it's to the negative 6th power. And since the only number that I have is just that 3, it's going to be 3 times 10 to the negative 6th power. And the negative 6th power would be millionth. So 3 times 10 to the negative 6, or we could read that as 3 millionths. Finally, I have 0. Let's see here. 0.000000067. I have my decimal in place already, so I want to move it until I get a number that's greater than 1, less than 10. 1, 2, 3, 4, 5, 6, 7. So I'm only moving it 7 places, so 10 to the negative 7th, and I end up with my number as 6.7 times 10 to the negative 7th. That's how we take numbers from standard form and put them into scientific notation. The next part that we have is we have numbers that are in scientific notation, and we want to move them into standard form. So for letter E, I have 4 times 10 to the 2nd. Here's my decimal for 4. Since it's a positive value, I want to make it a number greater than 1. So the decimal moves once, twice. What I've created are 2 baskets. And the one thing that the farmer likes to do is they like to put eggs in those baskets. So I'm going to put eggs in my baskets, and it's going to end up equaling 400. 5.94 times 10 to the 7th. That's letter F. So I have 5.94. The decimal needs to move. It says 7 places. So I'm going to go ahead and move it. 1, 2, 3, 4, 5, 6, 7. I have all of these baskets that the farmer wants eggs in. So I have 1, 2, 3, 4, 5. Are you noticing that the exponent doesn't say how many zeros there are? The exponent says how many times the decimal moves. I'll rewrite that number. 594. And then I put my commas in. Now I have 1.3 times 10 to the negative 3rd. So I have 1.3. Since it's to the negative 3rd, my decimal actually goes the other way. It's going to be a number smaller than 1. So I need to go 1, 2, 3. There's those baskets again. And I've got to put the eggs in it. And so it's going to equal 0 point, and then I put 0013. H. I have 9.51 times 10 to the negative 3rd. So I'm going to go ahead and move it 1, 2, 3. And I'm going to go ahead and put eggs in the basket. And I have 0.00951. And I'm going to put a 0 in front of it. So as a placeholder, that 0 in front of the decimal is just a placeholder. Now, the next thing that you're responsible for when it comes to scientific notation is ordering numbers from either least to greatest or greatest to least. Now, it's not so hard when it comes to ordering A, B, C, and D in scientific notation. It's not very hard at all, actually, to order those to order them when they're in standard form. We know that A is the largest number. And we should know, based upon the value of zeros, that D is our smallest number because we're not comparing 67 and 3. We're looking at the number of zeros, okay? The number of zeros tells us which one is greater in value. It turns out that D is a much smaller number than C is. So if we were to order these from least to greatest, we would say this is the smallest. We would say this is first, this is second, this is third, and this is fourth. Again, least to greatest. That's why that's the order that they're in. Now, when we want to compare the next set of numbers in scientific notation, we want to go ahead and compare those least to greatest. The way I do it when it comes to this is I look at my exponents. I compare my exponents. And you already know how to compare integers. Think about the number line. When you look at the number line, what's the largest number? What's the smallest number? Well, if I was just comparing these numbers, I could say -3 is small, and there's another -3, and then there's a 2, and then there's a 7. So I went ahead and I compared my integers. But there's 2 -3s that are listed there. So now what I need to do is I need to look at what's getting multiplied to 10 to the -3rd. What's greater? What's the smaller one? Let me take that back. What's smaller? 1.3 or 9.51? You should have said 1.3. So we would say 1.3 times 10 to the -3rd, and then we would say 9.51 times 10 to the -3rd. Then we would say 4 times 10 to the 2nd, and then we would say 5.94 times 10 to the 7th. And there we've just ordered our numbers from least to greatest. Please take a moment to write down any questions you might have about all of these notes that we've just taken. Thank you.